Hi students, this is Viswanath, chemistry faculty for NEET and IIT exams. In last class we completed numericals related to first order and zero order. Now see the theoretical part in this chapter, that is collision theory. Collision theory of chemical reactions. See this one. According to this theory, the basic condition for a chemical reaction is the collision among the reacting species. If we take some amount of reactants, then among the reactants collision takes place. Because of those collisions we can get the product. In this way this theory proposed this concept. Now collision frequency, the number of collisions that takes place per second per unit volume of the reaction mixture is called collision frequency. In unit volume or means 1 centimeter cube or 1 meter cube, in 1 second how many number of collisions take place, that is called collision frequency. It is denoted by Z. If more number of collisions takes place per 1 second in 1 centimeter cube of the volume or 1 meter cube of the volume, then we can say collision frequency is more. Next, effective collisions. The collisions among the reacting species which result in the products are known as effective collisions. Say this one, the collisions occur between the reacting molecules do not form products. That means all the collisions take place among the reacting species do not form products. Only some collisions can form products. That type of collisions are called effective collisions. So effective collisions means the collisions among the reacting species which result in the products are known as effective collisions. To make these effective collisions, reacting species should overcome two things. One is energy barrier and orientation barrier. Some of the reacting molecules can form effective collisions, means there is two barriers. One is energy barrier, another one is orientation barrier. See this energy barrier, threshold energy. The minimum energy possessed by the reacting species to make collisions effective is called threshold energy. So to form effective collisions, reacting molecules should possess minimum energy. That energy is called threshold energy. So the molecules which are having less energy than this threshold energy, they cannot form effective collisions. If the reacting species have energy less than the threshold energy, the collisions will not become effective, so that those collisions cannot form products. Next, orientation factor means direction. How the reacting molecules should collide in a chemical reaction, that is orientation factor. So the reacting species should collide in a proper orientation, means proper direction. They must face each other in a proper direction. Collision takes place between reacting molecules, then only we can get products, otherwise we cannot get products. So this is collision theory briefly. Okay, next, say this one, temperature dependence of the rate of reaction. How rate of reaction depends on temperature. See, in most of the cases the reaction rate becomes double, while in a few cases it may be even more than double for every 10 Kelvin rise in temperature. So for most of the chemical reactions, rate of reaction increases if we increase the temperature. That means with increase of temperature, reaction rate also increases, and in many cases it becomes more than double also for every 10 Kelvin rise in temperature. Suppose a reaction occurs at 300 Kelvin. If we raise the temperature by 10 Kelvin, so final temperature 310 Kelvin, at that 310 Kelvin the rate of reaction becomes double or more than double also. So rate of reaction is directly proportional to temperature. Now temperature coefficient, the ratio of the rate constants at the two different temperatures generally lies between 2 and 3. So at two different temperatures, if we take the ratio of rate constants, that is temperature coefficients. So temperature coefficient equal to rate constant at 310 Kelvin divided by rate constant at 300 Kelvin is equal to 2 to 3. Between 2 to 3, this ratio is there at these temperatures. So at two different temperatures, the ratio of rate constants is called temperature coefficient. Next, the increase in temperature may even initiate certain reactions which do not take place at room temperature. Some chemical reactions do not take place at room temperature, but the same reaction can take place at high temperature. That means if we increase the temperature, then that reaction takes place. See the example. Fuels like coal, wood always remain in contact with air or oxygen, but they undergo combustion only at elevated temperatures. In nature, we can see coal and wood always are in contact with air, but they do not undergo any combustion at ordinary temperature. At elevated temperature means at a high temperature only combustion takes place. So in this way, some reactions takes place at high temperatures and they do not occur at normal temperatures. Next, the increase in reaction rate with rising temperature is not due to the increase in the total number of collisions, but due to the increase in the total number of effective collisions. So what is the reason for the increase of reaction rate with the rise of temperature? When we increase the temperature, then the number of collisions increases, because with increase of temperature, the reacting molecules absorb that energy, then they make more number of collisions. That means by absorbing this heat energy, their energy is also reached to threshold energy. That's why effective collisions also increases, because of that reaction rate increases. Next, concept of activation energy. Many reacting species have less energy than threshold energy. Thus, the reacting species need some extra energy to reach threshold energy. This extra energy is called activation energy. Generally, reacting molecules having less energy, that energy is not enough to make effective collisions. So there is a gap between normal energy possessed by the reacting molecules and the threshold energy. This energy gap is called activation energy. That means some extra energy we have to supply to the reacting molecules to increase its energy to threshold energy. That extra energy is called activation energy. See the definition. The extra amount of energy which is supplied to the reacting species to make their energy equal to threshold energy is called activation energy. So we can write activation energy equal to threshold energy minus normal energy of the reactants. So symbolic form EA, activation energy EA equal to threshold energy E naught minus E. Okay. So this threshold energy, activation energy, we can represent graphically. For a general reaction, A plus B gives rise to D plus E. A plus B are the reactants, D plus E are the products. Now energy taken on y-axis, progress of the reaction x-axis. Reactant molecules having less energy than threshold energy, that is normal energy of the reactants. Few molecules having threshold energy. So by supplying extra energy, that means by providing activation energy, reactants molecules energy is reached to threshold energy. With this activation energy, reactant molecules form an intermediate complex that is called activated complex, that is C. So A plus B having low energy. When we supply this activation energy, the energy of these reactant molecules increased to threshold energy, then they form an activated complex. It is intermediate. This activated complex, by releasing energy, converted to products. So minus energy. Okay. Reactants form products through the formation of activated complex. That is, this is the graph. Okay. Next, say this: if the energy released by the activated complex in forming the products is more than the activation energy absorbed by the reactants, the reaction is exothermic in nature. This activated complex forms product by releasing energy. This released energy is more than activation energy of the activation energy absorbed by the reactants, then we can say the reaction is exothermic in nature. Okay. Now see this one. From this activated complex and to these products, this activation energy gap is more. This energy gap is more than this one. That means this graph represents exothermic nature of the reaction. Now another condition: if the energy released by the activated complex is less than the activation energy absorbed by the reactants, the reaction is endothermic in nature. That means this activated complex releases less energy than the activation energy of the reactants. In that case, the reaction is said to be endothermic in nature. Okay, we will meet in the next class.